Hello, and thank you for contacting Wave Support. I see from your request that you're struggling to incorporate some trial lens data into the design of this lens. And if I understand correctly, your initial design was very flat on the patient's cornea. So if we look at your design, and as we may have talked about in an earlier consult request, as you know, we don't have a whole lot of true data out here in the peripheral cornea, so Wave is really designing a lens based on absent data, and that's not a fault of yours. During the topography, it's just one of the problems we run into sometimes with these steep corneas. Wave has a hard time, or Scout has a hard time capturing this peripheral data. So really, if we look at your design, although your design looks very nicely aligned in the peripheral cornea, remember we're aligning it to data that we don't really know about. So we really have to rely on our clinical impression. And of course, your clinical impression was that these lenses were too flat on the eye. So let's look at a couple things. If we take this design, even though it's in free form, if you click over to the RSIM design, looking at the base curve over here, if you click to RSIM, you'll see that sort of the spherical equivalent base curve, if you will, is about 667, which is compared to the patient's habitual lenses, which I believe are 620 something. That's kind of a flat lens, so that might help explain why it's such a flat fit on this patient. So we want to see if we can get that to steepen up. Now I understand from your diagnostic lens that you placed on the eye, a lens that was about 620 or 6.19 in base curve seemed to give you a reasonable starting point. So we need to figure out how to incorporate that data into this lens. Now I mentioned in a previous training to use the tools data. One thing that may have not been clear, when you click on the tools, let me bring this up here. If you use the tool function for trial lens data, if you enter the data in here, this will adjust the lens based on base curve and power, but it won't change the base curve of the lens. It's more of a power adjustment than it is a fitting adjustment. So that's where I think you may have run into some difficulty on your second lens. So if we go back over here, what you need to do in that situation is try to mimic the shape of this lens, of your diagnostic lens, using some of the wave characteristics. So what I did, so what you want to do in this case, if you look at your lower right topography, you'll notice if you kind of look on that edge of that cone is somewhere right around 6 to 7 or so in that range. So looking at the trial lens data that you used, it had an optical zone of about 7, so that would be appropriate because that would put you right in the outer part of this cone. And so what I did is I did a little mock-up here. And what I did is I set this optical zone at about 7 and left the other points out from there. And then what I did is I designed the lens in freeform. Then I went back over and clicked here on the RSIM design. And based on this, I made the adjustments in this lens. So if we show you here in your original design, you click to RSIM, if you want to change this base curve, the sort of the spherical equivalent base curve, I'm going to click over to the 560 micron view. And then if you click down on the red dot, you'll see that 650 starts dropping. So you can make adjustments here in the blue and the red until you get that down to a more meaningful spherical equivalent base curve, which steepens that up. And then if you want to, you can click over to freeform then to take that same design and try to mimic more of the peripheral cornea, and that'll steepen that lens up quite a bit. So here's a design, and that actually looks very nice in your current design. I did a similar thing over here on a little smaller diameter, so I clicked over the RSIM, I got around 620, and you can go steeper if you want. Bring it even more down, that gives you your 619, and if you want to go even steeper, you can do that. I left the lens a little bit larger to try to incorporate a little larger landing zone, and I think using your 11mm would be fine. And then if you want, you can either leave it in that spherical or click to freeform if you want to try to capture a little bit more of this peripheral data out here to kind of get that lined up. And then I did not redesign it after that, because if you hit redesign using current settings, it'll go back and set this lens back the way it was before you made your manual adjustments. Now, at this point, now you can hit your tools function, hit your trial lens data, and enter the trial lens that you selected in your fitting. And I believe it was a -9. And then you can put in your over refraction. I think it was a 225, something in that range. at like 106 or so, whatever you had for your over refraction there. And then to continue, what that'll do, it'll adjust the power of the lens to be closer to that diagnostic lens. So that gives you a little extra data. And where that's helpful is on these, as you know, with these difficult corneas, sometimes the optical numbers just don't make sense. And so that gives you another way to sort of check the endpoint, or the sort of the general endpoint of that contact lens. And actually, most of my complicated corneas, I like to put a spherical RGP lens on the eye of known parameters and use that little power adjustment tool to see. And quite often you'll see that wave is right on with the calculation. And other times you'll find it changes the power of the lens a little bit here and there, and that can be very helpful, especially if you're dealing with monovision patients, or someone who needs a little more particular accuracy in the refraction. Well, hopefully that tip will give you a little bit more helpful guidance on using your trial lens data to incorporate in there. You can use that same philosophy as you know, their prior lenses. The patient had their prior gas perm lenses. You can put that data in here and adjust the lens so you can kind of mimic or simulate a lens that they were wearing. So I hope that gets you back on track. I wish you well with this difficult case. Thank you for contacting Wave Support, and have a great day.